Hello everyone, welcome back to another video in the Langchain projects playlist. In this video, we are going to see about an interesting project which is chatting with your YouTube videos. Trust me guys, this is the biggest project we have done yet in this channel because it will help you to chat with the videos, but the components involved in here are all open source and also it works in CPU. So I hope you all interested. Stay till the end of this video and try to do this by yourself also simultaneously. So without wasting time, let's jump right into the video now. So yeah guys, this is the end result we will be achieving at the end of this video. So here you can see the user provides a URL where once you provide the URL, the video will be displayed. Along with that, there will be a transcription which is generated here, right? So there is a button called transcript, and once you click that, the transcription will be displayed. So here it has provided a detailed transcription of the video, and once your bot is ready, you can ask questions to the bot, obviously, which means you are chatting with the video indirectly, where here the question is the type of visualization which has been used here to visualize the embeddings, and it has correctly said that hex bin is used for visualizing the embeddings. And yeah guys, it is pretty amazing because like I said, this is completely open sourced and all the components is open sourced. Also it runs in your CPU itself, so that is why it is pretty amazing. So let's now see what is the workflow of this application. Yeah guys, so since we have completed to see how is the application, now it is very important to know the workflow. So that is where we are now. Here if you see in this the transcript part generation, right, there was this transcript being generated here that would act as a separate application. Even in one of our previous video, which is YTBuddy, we created the vector database locally and then we ran the application, right? So similarly, due to CPU computation issues, we'll be running this transcription part in a separate way. Okay, it will be a separate file, and other all will happen at runtime itself, being the vector store creation or else your question answering, all will happen within the Streamlit app. But these alone, you giving a URL and then the video being downloaded and then transcription being generated, all will happen separately. Okay, so now we'll start with the workflow. As you can see here, the URL will be provided by the user, and once the URL is provided, the video will be downloaded first. And once the video is downloaded from the YouTube, what happens is the audio alone will be extracted. Okay, because we don't need the video, right? We need only audio so that we can generate transcript out of it, and based on that we can do some question answering or even summarization is possible. And if you guys think you need summarization, let me know in the comment section. I'll try to make a video on that as well. So once the audio is converted from video, the audio is created, next step would be to generate the transcript, right, for which we'll be using OpenAI's Whisper. Okay, trust me guys, it is a pretty amazing model, but we are not using their API key. We'll be using Whisper from our local itself. Okay, so once the transcription data is created, we'll be loading it via text loader, where it will be passing from data 1 to data n chunks. Obviously you might know what is data chunk right now. So if you don't know what is data chunk, stay for some time. I'll be explaining in the later part. So once the data chunk is created, we'll be computing embeddings for the data chunks, and those embeddings will be stored in the FAISS vector store. So now the FAISS vector store will have the embeddings for the documents which can be indexed later. Okay, now the second part is completed. The first part would be to generate the transcription, and the second part would be to compute the vectors for the transcription. Okay, so now these two are completed. Now coming on to the third part, where once the user provides a query, which is the question via the chatbot, we'll be computing the embeddings for the question also, and then based on that we'll make a semantic search in the FAISS vector store. And once the semantic search is completed, we'll be ranking it from top to bottom based on the relevancy, and here we'll be taking the top 1 result, or else even we can take top 2 result. Okay, that is also fine. So once you take the result, then we'll be passing on to our Llama model, which we will be using here, and then finally we'll display the answer. And sorry, I left here. So once the transcription is generated, we'll be displaying the transcription also. You would have seen, right? There is a display for transcription. So this is the overall workflow, guys. If you find this overwhelming, don't worry. I'll break it down step by step once we are going file by file. But yeah, this is an overall idea of what flow you can expect from the application. All right. So now let's jump on with the WhisperTranscribe part. Okay. So let me cut all of these. If needed, we'll open the images. Okay. So first what happens is here, before we are going on to the code, let me tell you all that you need to install some dependencies. Okay. So the dependencies would be solved when you install this requirements.txt file, but there will be one dependency which you can't solve via this. What you need to do is install ffmpeg package via conda. Okay, conda install conda forge ffmpeg, if I'm not wrong, is the command. But even if you make a small Google search, you will be able to find what is the command. In Stack Overflow it would be there. Okay. Along with that, others should be fine from here. Okay, so we'll be installing Whisper from the GitHub itself. And guys, if the requirements is not working, let me know. I'll create a requirements.txt by myself, and then I'll also provide it in the description. So yeah, that is about installing dependencies, guys. So first install this. Next we'll go on with this Whisper transcription part. For this we will be using PyTube, which is a Python library for downloading YouTube videos, and then another one is we'll be using a package called Haystack. Okay, so similar to Langchain, it is also another package which will provide you a framework to create applications by using LLMs. Okay, so here we are using WhisperTranscriber, which will enable you to transcribe the audio files by using OpenAI's Whisper. So now we'll move on with the transcription part. So here we are having a class called transcript generation, and in that, first when we are initializing itself, we are initializing the WhisperTranscriber part. So here you can see it is asking API key, and you might think, Vasant, you said that we don't need API key. Yes guys, you don't need API key. Once you complete the installation, like I said, once the requirements installation is completed, you can just have this WhisperTranscriber as it is without providing API key. It will take the Whisper model from the local itself. It will work. Okay, so next step, like I said, is to create the audio, right? Like we need to extract the audio in the workflow we saw, right? Let me put the workflow now so that we can have comparison here. Okay, so here is the workflow. We now got the URL. Obviously, from where we'll get is we'll get the input from here. Obviously, like I said, this is a separate file, so we'll get the command line interface input. Okay, so that's why we have given it as input. So once the URL is got, first thing is to download the video, where we'll be downloading it from this file itself. Sorry, this function itself, YouTube video to audio, where once you create this YouTube class, right? Once you call this YouTube class, and once you do this filter, what it will do is it will try to extract the audio alone, and then it will download it. Okay, so that is how it will work here. So given a URL, it will try to extract the audio, and then it will be downloaded. So once you download it, you will be able to see a WebM file here. Okay, so if you're thinking, okay Vasant, there is no file here, I just deleted it obviously, but when you run it, you will be able to see a file, which is an indication that it is working. Okay, so once this is done, let's now see the workflow. Obviously the next part would be, once you have the audio, is to transcribe it, right? So for this we are having a function called genTranscript, which will take the video URL obviously. So what we are doing is, so here if you see, we are getting the input. From there we are calling the genTranscript function. In the genTranscript function only, we are getting the audio path via calling this function. Okay, so what happens is it will create the audio, and then the path will be stored here. Okay, so the audio path will be used by the Whisper. Okay, there is a transcribe function from the Whisper which will transcribe the audio file. As you can see here, it expects audio file parameter, which is a path. Okay, so yeah, audio path, even if you have audio file being loaded, that also can be used here. So once you transcribe it, obviously you will have the transcription. What you can do is you can just write it. Okay, write it in a separate file, in a txt file. That would be fine. And if you're wondering, Vasant, can I do all of these also in runtime? Yes, still you can do if you have bigger CPU RAMs. Sorry. So I have a RAM of 16 GB, which is correct for running the Llama model for question answering. That itself, it is going good. But if you want to do this transcription part also in live, still you can try, but don't hang your system. But if you're sure that you're having 24 gigs of RAM, I'm very sure that you can just integrate this part also in the Streamlit application itself. Okay, so all will happen in a single application. So here what we are doing is, in transcription, if you see, it would be a dict. The returning type would be dict actually. So here you can see, right, dict. So what it would return is, it will return the language as well as the txt file in which the transcription would be there. Okay, so both keys will be there. There will be a text key as well as there will be another key called language. In language it would be en, and the text key will consist of our transcription. So here if you see, we are opening the transcription.txt file, wherein we are opening it in write mode, and we are writing the transcription inside this transcription.txt file. But guys, if you want, you can also do this for multiple videos and have multiple txt files. And if you are wondering how to load the multiple files, don't worry, the code is already set up for loading multiple txt file. You need not worry about loading multiple txt file and all. Okay, so if you are thinking, I have parts of videos, like let's say I have a research paper video, which is, for example, a DPO video, where I have implemented it in a separate video and the explanation is in a separate video. But if you want to chat with both, like, first understanding the concept and then trying to understand the implementation side by side, still you can do this 2 times. That is where this gives you an advantage of running it in prior. Okay, so you can just run this 2 times with 2 video URLs, and then what you can do is you can store the txt, your transcription, and then you can load it in the Streamlit application. Okay, so that is also possible. So here if you see, we are returning the transcription also, so that we can just see if the transcription is there. We are just printing it. Okay, so for this you can just write it as Python your path for this file. Okay, so here it is source/whispertranscribe.py, and then you can also do the same, and then provide your URL by which your transcription is ready. So you are done with the step 1 right now. What is the step 2? So here if you see, the step 2 is to create this vector database, right? So till this you can consider it as our step 2. So now let's see how to do that. Okay, here if you see, there is vector database, and guys, from now on all these will happen in runtime. Okay, in your application itself. Only WhisperTranscribe will happen prior. That component alone will be computed separately, but others all will happen in runtime only. Okay, here if you see, we are importing Hugging Face embeddings, which will instantiate a sentence transformer embedding model, and then we are having FAISS vector store, which will store and then perform our vector search. And then we are having document loaders here, where there are 2 loaders which we are using, directory loader, so that we can load any number of files from the directory by using a text loader, because here we are only focusing on txt files, right? We are only writing .txt file. So next we are having recursive character text splitter, which will split the data into chunks. And then finally we are importing the config. These are all some conventional imports, right? So here if you see, we are having a function called FAISS vector db, and then it will be returning a string stating that vector store creation is completed. Why the string is written, we'll be seeing that when we are seeing the application code. Okay, so here you can see, in directory loader I'm taking the data directory path. So we'll keep the config now here. Okay, in data directory path I have said that data / is the data directory. Okay, so in that I'm using glob here, which will try to find which are the files I need to extract. So here I have said that any file with a txt extension should be considered. Okay, so star.txt means that any file name with .txt as extension. So for loader class we are using text loader, which will load the files which is being loaded by the directory. Okay, so what happens is, first the directory loader will try to load the files alone, and then the text loader will load it as documents. Okay, so this is how directory loader works. Next step is to see the workflow first. Okay, let's have the workflow. Like you see here, we have the transcription data, we are loading it via the text loader. Next is to split it into data chunks, right? So here if you see, we have recursive character text splitter, which will be a text splitter which will split based on the chunk size provided and chunk overlap provided. So what is chunk size and what is chunk overlap? So in chunk size, what happens is it will take the number of characters which we give here. Here if you see, the chunk size would be 500. Okay, so 500 characters is considered to be one chunk size. For computation purposes, I have kept it very low, but if you want, you can also keep it very high, like even 5,000, 10,000 is also possible. Okay, so in this chunk size, what happens is, first it will try to create a chunk from 1 to 500 character. Okay, so the next chunk would be 300 to 800 and so on and so forth. So the advantage of this is that the context in which you need to ask the question would be reduced. 1, 2, by chunk overlapping, you will not lose the context, right? Because there is a bridge of 200 here. So that 200 characters will be almost suffice enough for this 500 chunk size. So yeah, so this is just to keep the context size very low. What happens is, usually when you give these chunks, right, when the user provides their query, they will be obviously computing their embedding and the most relevant chunk will be returned, which means, for example, if you are having a 5,000 character size chunk and the answer would be in 500 characters, okay, so instead of passing the 5,000, we'll just pass this 500. That is why we are doing this chunking. All right, so I hope this makes sense now. Now we are splitting the document obviously so that we can create data chunks. Okay, so next we are having Hugging Face embeddings class, which, like I said, will initialize a sentence transformer, for which we have used GTE large according to the MTEB leaderboard. Okay, so you can just type in Google MTEB leaderboard Hugging Face. You will be able to find that this model is one of the top 3 models performing in creation of embeddings right now. Okay, so, and like I said, we'll be running this in CPU. So we are explicitly specifying that the device should be CPU, because if you see in my system, I have CUDA being enabled, but I'm saying that only we should use CPU, no CUDA. Okay, now once we are done with the embeddings, Hugging Face embeddings will create your embedder, right? This embedder will try to embed the input documents, and those documents will be stored in the FAISS vector store. Okay, so that is what is happening here. So FAISS vector store then will be saved in local in the vector database path provided. So here if you see, the path is FAISS/video chat. Okay, so in this, if you see, there is index.FAISS and index.pickle. So that is how the vector store will be created. Now let's see how this will be called. Okay, for this we need to go for our application. Okay, so here if you see, let me go to this place. Okay, when you click that chat with video button, right, when you click that, a bot will require this vector database so that it can retrieve from there. So the first step at that time would be to call this function called create vector store. Okay, so here only I'm calling this FAISS vector db, and then here if you see, I'm just storing it in a variable, and I'm printing st.success of vector store, which will print st.success of vector store creation is completed. This is the indication. This is why we had this. Okay, so here it is showing that vector store creation completed. For this only we had that being returned. Okay, don't worry if you think, okay, Vasant, this is somewhere in the middle. Obviously I'll be going through the flow of the application one by one. I'm just showing you where this vector db creation function is called. Okay, so now if you see, the 2 major components is completed, where vector store is created, and then we also have the transcription, which is being the input of the second component. Now the third component would be to have the user query, and based on the user query we need to provide the answer. Okay, and guys, without forgetting, just see here, we are also displaying the transcription. Okay, for that, if you see in this application also, here if you see the transcript, right, st.success of transcript, what it does is it will read the transcription.txt file from the data, where it is obviously generated from the Whisper. So that will be displayed here. Okay, so that is how it is happening. Now yeah, we'll move on with the bot part. Okay, how to create the retrieval QA chain which will act as our bot. For this we'll need to see the YTBuddy.py file. Okay, so yeah guys, here we have the YTBuddy file. So if you see, this is the function which we'll be using to create the bot. So let's go in that flow itself for better understanding. So the first step would be to create the custom prompt template. Okay, so while initialization we are using the self.prompt template. For this it is being called from the config file. So here if you see, we are stating that the model should generate only relevant answers, so no irrelevant answers should be generated. So that is what is happening here. And there are been people who have been asking me why this context and question is provided here and where it is being passed from. Okay, so here if you see in the YTBuddy.py file, I'm providing a value for input variables, right? So this is, as you can see, the name itself is saying that the description of the name, a list of the names of the variables the prompt template expects. Okay, so these are the variables that the prompt template expects and we are providing that, that's all. Okay, so here we are stating that context and question are our variables. Okay, so here you can see we have context and question being provided to the prompt template. Based on this, what will happen is whenever you retrieve a value or else a document rather, it will become your context and the user query will become the question. Okay, so that is how it happens. So that is the custom prompt template. So once this is done, the next step would be to load the vector database. This is not just about loading the vector database, but it is also creating the embedder. Why? See, the point is when you have the user being provided the query, we need to compute the embeddings for that also, so that we can make retrieval from there on, right? So that is why we are computing the embeddings, the embedder here. First we are creating the embedder here and then we are loading the FAISS vector store from the local. Okay, so this would be used as the retriever. Okay, so that is why these two are provided first, and then the next step would be to load the LLM. Okay, so let me click the load LLM here. Here we are gonna use, let me show you here from the config file. Here if you see the checkpoint would be provided, which is Llama to 7 billion chat ggml v3 q1.bin. Okay, q4.bin. So this is a file which we are using for all the Langchain projects till now. So this is providing some tremendous performance and I hope you all know how to download this. So if you don't know, please check out the previous videos and all. And if you just want the link to download, just click in the description. I have provided the Llama model link. You can get the model from there. So it is a 4 GB file. You can download it, or else if you are having lesser RAM than me, like you are having 12 or 8 gigs RAM, try for a smaller model. There is a variant which is 2.8 gigs or something. You can just have that. Okay, and then replace this model checkpoint here. So now coming on to this model creation part, we are stating that the model type is Llama. So here you can see, right, model type is initialized here, which is Llama. Max new tokens is 500, which is stating that I'm allowing a generation up to 512 tokens, and the temperature is 0.9, which will control the randomness of the generation. Closer to 0 is more diverse, closer to 1 is very strict. Okay, so now once we have the prompt template, the LLM, the vector database, now it is time to create the bot. Okay, so finally we have this create bot function. What it will do is it will use retrieval QA chain. Okay, so obviously Langchain will have everything as chain because it is a chain of component. So here we'll have LLM being provided. The chain type is stuff where all the document retrieve will be combined into a single document. So the retriever is our vector database. Our vector database only will act as a retriever because FAISS is very good in vector search due to its quantization method. Okay, so in this we are providing a main parameter which is search quarks. Okay, so let me show that also here. So here if you see, it is a dict. Okay, and here you have k being provided as 2. Usually when we are doing retrieval, right, we'll say top k usually. Okay, so top k means top how much result you want. I need top 5 results. Then means what happens is it will, like I said, rank all the results and then it will take the top 5 results. So here I'm saying top 2. in the workflow we gave one also, right? You can also try to provide one. For just some leniency there, I've provided 2, but also you can provide 1, or else if you think I need more leniency and more context, provide 3 also, that is also fine. So that will act as a retriever, and we are providing the prompt template as well. Okay, so this is how the retrieval QA chain is created, which will act as our bot. Now we have our bot, we have the transcription generated, we have the vector database. Now all is left is to integrate this all into a single application, okay, which is the app.py file. So yeah everyone, here we have the Streamlit application. So here if you see, we are importing some important dependencies. Obviously Streamlit is there because that will be our user interface, and then we have Streamlit chat. So if you see, that is the framework which we will be using to have this chatbot interface. Okay, so for those who have been following our videos, I hope you might know how this UI is going to be framed up. Okay, so here if you see, we have a vector database being imported because if this function is called, right, FAISS vector database, we know that it is going to be saved in local. And then the YTBuddy creator class is called, so that we can call this specific function create YTBuddy bot to make an instantiation, which is an object of the bot which we can interact with. Okay, so let us go step by step. Okay, so here if you see, we are setting the page config to be layout as wide, because here if you see, usually these will be in center. Okay, center of the application, usually that's how they have configured it. But to have these 2 columns, like these big components, we need a lot of space, right? So for that we have set the layout to be wide, okay, so that it will take maximum space from the user interface. And also we are setting the title to be YTBuddy chat with your YT videos. Okay, let me come to these functions next. The first step here if you see is to get the user's YouTube video URL. Okay, so for this we are having a text input box in which the user can provide the URL. And then the next step here if you see, we are maintaining a session state called clicked, which is not very usual till now. We usually don't maintain this state called clicked, right? Why I'm using this in this specific video is, when I clicked some buttons, right, always the values will get disappeared. All the values which is present in the application will disappear, which means all the components will disappear and the application will restart from the first place, obviously. So to avoid this, it was suggested a solution that you should maintain a session state called something for which it makes sense that clicked makes sense, so that all the issues were arising due to when we are clicking it. Okay, so I was maintaining a session state called clicked, which will hold all the session, like it will be whole, like the application won't be restarting at all. So this is a solution for your problems which you might face. Okay, so if you face a solution when you are clicking or else providing value and your application is restarting, just have this session state called .clicked equal to true, and before you do anything in the application, just make a condition check stating that if your session state .clicked is true, okay, then the application will work smooth. So here if you see, we need 2 session states for our chatbot. One is user and then another one is assistant. In user obviously it will be empty, and assistant also will be empty, because we even know that the session state won't be there. So in this we are stating that the first user conversation would be hey there, and then the assistant would reply I'm ready to help you. So this is the first conversation. Followed by that, any conversation would be followed by we providing some question, and then it will provide answer here. For example, we have a question stating that what type of visualization is used to visualize the embedding here, and it has said that it is Hexbin. Okay, so these all will be stored in these session states, assistant and user. So now coming on to this specific part, we have this URL now. Next we'll move on this specific place where video and chat with the video. So if you see, it is splitted, right? It will be in 2 specific part. It is like 2 specific components. So to make it appear like this, there is one function called columns, which will create containers. Okay, so it will be side by side columns. You can have multiple columns as well, it's not a single column, but here we need only two columns. So I have made that the spacing should be equal, so that is what this one is specifying. But if you provide 0.5 here and then some bigger value here, it will try to provide the values accordingly, sorry, the space accordingly based on this value. So if you see in this first column, we are displaying the video, so the subheader is video, and then we are rendering the video based on the URL provided by the user. And then the column 2 starts with chatting with the video. Okay, so next is this expander. Okay, so like I said, we are computing the transcription in the early stage itself, but if you are going to do this in runtime, this is the place. Okay, so if you are going to compute in runtime, just comment these 3 lines, okay, and then compute all of those transcription here with expander of transcript, compute this and then print the transcript here. But since we are doing it in prior, what we have done is obviously we have wrote it in a file called transcription.txt, right? So here if you see, we are opening it and we are reading it, and we are having it in variable called transcript, which we are writing it in a success message so that we'll have this green background. Okay, so if you write it as a normal write function, it will write it without any background. But here if you see in this transcript png file, it is clear that there is a green background, right? To make this green background appear, you can use this success function. Similarly, there are other functions as well, like warning, error. There are a lot of other functions as well for different colors. If you want, you can just experiment it. Okay, so now coming on to the chat with video function, which will be holding our chatbot. Okay, this container will be holding our chatbot. Like I said, guys, expander is another container, column is one container. Inside that column we are having 2 other containers, so which is transcript, that is one container, another one is a chatbot. Okay, so in this if you see, we are calling 2 functions. First one would be the create vector store, which will call the FAISS vector db. As you know, what it will do is it will take all the data transcription, it will chunk it, it will create a vector store, and it will be saved in local. So that is what we are doing it here. But you might wonder why this cache resource. See, whenever the app reloads, the creation also happens from first, which is waste of computation. These are not going to change, right? These are some standard ones, so you can just cache it so that the reloading can be avoided. Okay, so once the vector store is created, obviously we are ready for bot, because the bot requires 3 main components: prompt template, your vector store, which will act as your retriever also, which is FAISS here, and then we'll have the LLM and custom prompt template. We are loading it, so it doesn't depend on anything, but it depends on vector store creation. So first we are doing create vector store, followed by that we are creating the YTBuddy by using this function create YTBuddy bot, and we have made a walkthrough of this, right? So I hope you all understood till this. So what we are doing is we are just displaying a message stating that the YTBuddy is created here, and there I said I'll say why we returned a string here. This is just to say that vector store creation is completed. To display this message only, we were returning it from there. So here you can see, right, vector store creation is completed, YTBuddy is created. To display those messages only, I returned it like that from there. Okay, and here if you see, I have provided you guys with the spinner here so that it will show when it is running. It is better for a user to understand why the time is taken. Okay, so when you are running this, if you are showing a spinner stating that the YTBuddy creation is in progress, the vector store creation is in progress, they will understand, okay, something is going on, let me wait until then. Okay, so that is why the spinner is here. So once you create your YTBuddy, which is a retrieval QA chain, so the next step would be for you to get the user's question, which you should answer obviously. So for this we are getting a text box again, which will take the user's question, and once the user clicks this answer button, what happens is this user query will be going on to this info function. So what this info function has, this info function will take the bot, which will be providing it, the YTBuddy bot, and the prompt. Okay, so for this prompt obviously it will take a dict. So here you can see I'm providing query, don't change this key. Okay, so this is expected by the retrieval QA chain itself. So have the key as query and provide the value which is your user query here. So what it will do is it will return a dictionary output in which our expected output will be under the key called result. So we are just taking that alone from the result, and then we are returning it. Okay, so here if you see, once you return this, we are appending this answer to assistant session state, because this is generated by the bot and the user query is provided by user, so we are appending those into user session state. Now we are done with the conversation. We need to display the conversation, right? So for this, we are making sure that it is in assistant session state now, which means that the assistant has answered now. And then we are going on to the display conversation so that we can display all of these as a chat here. So here we have the chat, right? To display this, we are calling this function here, where we are going through the history of conversation, in which the user conversations are specified that is user equal to true, which will have you this smiley image, a smart guy obviously, and then the message is at the right side. Okay, if you don't specify that, it will be on the left side. Okay, this is what will happen in the display conversation. And finally, voila, you will have your application ready, which will help you to learn. And then yeah, this is also a good resume project for you all to show in your resume, right? So this is a great project, guys. I hope you all like this video. Like I said, this is the biggest project which we have done yet in this channel, and more are to come. Okay, so yeah guys, that's it for this video. I hope you all like this video. If you like this video, please hit the like button. It will be a great motivation for me and an indication stating that you all like these kind of videos. And comment your opinions in the comment your opinions and suggestions in the comment section, and also mainly share it with your friends, guys, because these kind of videos might help a lot of people. So share it with your friends and communities, and ask them also to see these videos, and hope they might also find this very useful. I'll see you all in the next video, guys. Until then, cheers.